Okay, so this is our O-level mathematics on our transformations, which is the geometrical transformation. We are going to have this part from our introduction up to the end. So just do yourself a favor, make sure that you watch these videos from this one up to the end, so that you do understand what is it that you are required to have or that you need to know in your syllabus for these geometrical transformations. So like I said, this is our introduction, but we're going to focus with the translation on its own. But I just want you to know what you're going to have as we are moving on. So under geometrical transformations, we are saying, let us just consider a point that is that is located on our Cartesian plan. We are given a certain point on the Cartesian plan. Remember your Cartesian plan, that is this plan of x and y axis from our algebraic graphs. Talk of any graph that you had before. You had a Cartesian plan. So let's consider to say there is a point which is situated here, that is point A. Originally, that is where it is situated. That is where it is, that is where you have marked your point. Like you have marked your point A, maybe that's 1, 1, or it's 1, 2, whatever that you've marked there. That's your original point. Then we will be given that this point is now moved from where it is situated here. This point is now moved. Maybe the point A is now at this point, and now we refer maybe as A1. All right. By the fact that a point has moved from where it was originally here, the fact that this point is no longer situated where it was before, it means the point A is transformed. The point A is transformed from where it was to this point. It is transformed. That's the transformation. So transformation simply is the change of the position. Change of the position referring to a point. The point was here, now the point is here. It has changed its position. So transformation can be change in position. At the end, you can say it's for change in position. So that change that occurred in the position, you need now to describe the transformation that occurred, the transformation which transpired there. What is the transformation? That is to describe the transformation. So it is very, very important that you know, you need to know each and every transformation, like I said before. So like I said, the transformation can be of the change of the position. It's not just about the position, because let's talk about a shape. Let's refer to a shape. Maybe there's a triangle that is given there as ABC. Then later on, we see this triangle. Now this side is a bigger triangle like that, or it can even remain with the size, the same size that it had before. It can even remain with that same size, or it can be bigger. The fact that the triangle is no longer at the position where it was, it is now at a certain position. That's a transformation. So as we can see, in terms of a shape, it's not just about the change in position, it's also about the change in size. So transformation can also be referred as the change in size. That's transformation. So you need now to describe that change in size. You need to describe. change in size. All right, so like I said, this will be our transformation. So a transformation simply means a point can change its position. So a point can be transformed at the end. A shape can be transformed. A point. When I'm talking about a point, A is a point, maybe 0.21. So a point can be transformed. You can transform a point. A line can be transformed. A line can be transformed. All right? You can transform a line. A shape, complete shape. That's you are considering now a complete figure, a complete shape there can be transformed. Is it a triangle? Is it a rectangle? Whatever that you have, any shape, anything can be transformed. Anything. So that is what you need there. So the transformations that you have in your syllabus for your O-level mathematics, you are going to have 6 transformations that you need to know. So the types of our transformations there, these are the types. So the types that we have, we are going to talk about the first 3 transformations, which when you transform the shape remains as it was originally, but just it has changed its position. The shape is not changing like its size. Okay, let's go back to our normal mathematics in our normal shapes. Remember, there's a topic, congruence. When we refer to figures which are congruent, whatever that you see on the first figure or whatever that you see on the first triangle is exactly the same as what you see on the other triangle. That is to be congruent, not similar, not to be similar, no, to be congruent. So when the shape that is being transformed from where it is to the image, from the object to the image, the 2 figures are congruent at the end, meaning to say same shape, same size. If this is occurring that the figures are congruent, exactly the same, but only that the position is the one that has changed. The triangle was here, now the triangle is here, but same triangle as it was. It's not changed. That is where we are going to expect 3 types of transformations, which is the translation. The translation. Number 2, the reflection. Number 3, the rotation. These 3, they do like for you to think about these 3, just to think about these 3, just to think of a translation, to think of a reflection, because each is going to have its own property. But just to think that, okay, I'm thinking that this is a translation. You cannot consider that when the object is like this, when the object is like this, then the image is like this. You cannot think of a translation. You cannot think of a reflection there or a rotation. You can't relate to this. Why? Because I'm saying these transformations are from the figures that are congruent, the figures that are of the same shape, same size. This one, the size has changed. So we cannot think of a rotation there. We cannot think of a So these 3 transformations, they are taken from congruent figures. We call these isometries. All right? From congruent figures. Okay. So as long the shape is the same, size is the same, you think of these three transformations. So we are going to separate them now. That is where we are going to talk about a translation on its own. But for now, we are seeing that just for you to think of just to think that it can be a translation, or it can be a reflection, or it can be a rotation, it's from this part. Then we have got the other three that will remain. These ones, I'm going to explain them on each part. I'm not going to explain about these now, but these are not isometries now. These are no longer isometries, where we talk of the enlargement. That's enlargement. There we talk of shear. So the shear now, we are going to talk about that, like how to express, how to see that this is shear enlargement and so forth. No problem. I'm going to talk about that. Then we also have a stretch. So the stretch can be one-way stretch, or it can be a two-way. We're going to talk about that. So this one can be expressed into two. We can have a one-way stretch, and we can have a two-way. So it's going to be two ways, just two-way stretch, not to confuse you guys. That's it, two-way stretch. So what I'm trying to say is that you will need to know these 6 transformations, these 6 transformations, each with its own property, each with its own property. There's just its own property that you need. Be very, very watchful when it comes now to the separation of these transformations. So meet me up in the next class, as I'm going to talk about the translation and other transformations separately, so that you won't have a misunderstanding. At least if we work on these ones separately, you understand me as much. But for now, just write the notes on this part, just to know that these are the transformations that I'm going to work with in the syllabus, so that you'll be equipped to prepare for each transformation.